Okay, we're going to begin Chapter 3 by solving systems of equations. So the mathematical practices will be reason abstractly and quantitatively and attending to precision. Previously, you've graphed and solved linear equations. Now we're going to solve systems of linear equations. That means one or more equations. And we're going to solve them both graphically and algebraically. New vocabulary is break-even point. So when we're talking about system of equations, that's where two equations would cross. Systems of equations is two or more equations with the same variables that we're trying to solve. They can be consistent, inconsistent, independent, dependent. We're going to use the substitution method algebraically and the elimination method. To solve a system of equations with two variables, we need to find the ordered pair that satisfies all of the equations. So here we have two equations, and so what we're trying to find is the ordered pair that would make both of these equations true. They're first going to show you how to do this using a table. Now, I need you to understand how to use the table, but that's usually not the method that we normally choose. So we're going to solve for y in each equation. So we're going to subtract the x from both sides on the first equation. We're going to add 2x on both sides to the second equation. So notice these are both in slope-intercept form. Now we're going to use a table to find the solution that satisfies both of the equations. So notice that we have our x value that we're going to choose. This is the first equation, and this is the y value we get when we substitute in this x. The second equation, y is equal to 2x minus 6. So when we substitute in the same x in the second equation, this is the y value we get. So the ordered pair for the first equation will be 1, 2. Notice how we've written that there. And then for the second equation, 1, negative 4. So this is how they've got each of the solutions in this table. Notice on this last one, when x is 3, we get a 0 for both of the equations. So our solution is going to be 3, 0. So find the solution to this system of equations using a table. So pause the video and then come back in a moment and check your answer. Did you get 0, 2? If you did, very good for you. Now we're going to learn about solving by graphing. It's another method for solving a system of equations, and what we do is we just graph both of the lines on the same coordinate plane. The point of intersection represents the solution, or in business terms it's known as the break-even point. So again, we're going to put both equations in slope-intercept form, and the graph appears to intersect at 4, 2. Now we're going to check our answer by substituting the coordinates into each equation. We're going to use the original equations, and it's very important that you do it for both of the equations. So we got 2 and 4 for 4 for x, and 2 for y. So we substitute it in, and it does check 0 equals 0 and 6 equals 6 every time. So the solution to this system of equations is 4, 2. Notice the x is always written first and then the y value. Time to check your progress. So which graph shows the solution to the system of equations below? So pause the video. Remember, first of all, you need to write each one in slope-intercept form so you can graph your line and see where they cross. Did you get A? Very good. When you solve for y, did you get for one, y is equal to negative 1/3 x plus 7/3? And then on the other one, y is equal to x minus 3. Don't forget, you're not solving for a negative y, but a positive y, so you have to multiply every number or by a negative 1 or divide by a negative 1. Now we're going to classify systems of equations, and we're going to have a key concept at the end of this little section that you can put in your notes so it'll be all nice and neat. But we're going to graph the system of equations and we're going to describe them as either consistent and independent, consistent and dependent, or inconsistent. So if they cross it at least one place, they're consistent. If they don't cross, if they're parallel lines, they are inconsistent. Now, if they cross at exactly one spot, they're consistent and independent. And if they end up crossing in more than one spot, or other words, they're the same line, they're consistent and dependent. So you can replay this if you want to take those notes, or know that we're going to be writing those down at the end of the video. So first of all, again, write each equation in slope-intercept form. So we're going to solve for y. Notice they're not the same line, so already we're throwing out consistent and dependent, so it's between consistent and independent and inconsistent. So we graph them, and they cross in exactly one place. So the solution is 2, 3. There's one solution, so they're consistent and they're independent. Now let's graph this system of equations and describe it. So what's the first thing you're going to do? You're going to write the equation in slope-intercept form. Good for you. Oh, look at there. They're the same line. So because they do cross, they're consistent, and because they're the same line, they're consistent and dependent. Very good. Okay, let's graph this system of equations and describe it. First of all, we write the equation in slope-intercept form. Okay, now notice the slopes on these two lines. They are the same. So what does that tell you about those lines? Why, they are parallel. Very good. So because they never cross, they are inconsistent. This one has no solutions that can satisfy both equations. Okay, now let's graph this system of equation and describe it. Now notice we're comparing 3 different lines now. Oh, looky here. They're already solved for y. They're in slope-intercept form. Notice these two have the exact same slope. So f of x and g of x, there's f of x and g of x, they're consistent and dependent because they are the same line. F of x and h of x, they're consistent and independent because they cross in one point. And g of x and h of x also are consistent and independent because they cross in one place. Okay, time to check your progress. So pause for a moment. What are you going to do first? Did you say solve for y? Very good. You're going to put it in slope-intercept form. Then graph them to see what their classification is. Very good. They cross in one place, so they're consistent and independent. Now pause the video for this one and we'll check it out. Oh, they're the same line. They're consistent and dependent. Very good. Let's check this one out. They're inconsistent. They've got the same slope, they're parallel lines, so they're inconsistent. They never cross. And this set, which statement is not true? It's not true that f of x and g of x are consistent and independent. They're not consistent. They're parallel lines. They don't cross. So very good. As I promised, here's the concept summary. This would be something very good for you to pause the video and draw into your notes. It's also in the textbook if it's easier for you to read there. But you need to have this in your notes handy so that you can use it later on for your assignment. Now we're going to talk about algebraic methods for solving systems of equations. So if you want to take a moment and make a note of this key concept, and we'll go over what this means in just a second. Okay, I want you to take a minute to read this word problem. It's a real world problem. So this is why we even need to understand how to solve systems of equations. Okay, notice that a rocking chair sells for 265. So let's call that 265x because we're trying to find out how many of each chair. So 265x plus 320y equal 13,930. Notice all these dollar signs. If you have difficulty, and if there's dollars and numbers, you can put the dollar signs together. 265x plus 320y equals 13,930. And we're trying to find out how many of each. So x plus y equals 48. So those are our two equations. Now with substitution, what we're wanting to do, since one of the coefficients are 1 with x and y, let's solve for x in terms of y, which means solve for x, and it still has a y in the equation, but we're solving for x. Now we're going to substitute 48 minus y in place of x. That way there's two y's here, and we can combine them, and we can solve for y. So we're going to use the distributive property. And 320y minus 265y is 55y. Okay. We're going to subtract 12,720 from both sides. So y is equal to 22 when we divide both sides by 55. Now what we have to do is go into either of the original equations. Wouldn't you rather work with the smaller? You don't have to multiply by anything. So we're going to put a 22 in place for y, solve for x. So we sold 26 rocking chairs and 22 Adirondack chairs. Don't you like that word, Adirondack? Now you can use a graphing calculator to check your solution. So if you would like to know how to use your graphing calculator, if you have one of your own, call me over early the next day when we're working in class, and I will show you how to put that in. Okay, time to check your progress. So pause the video, read through the problem, and come back and check your answer. Very good. 120 adult to 10 children. So did you go 2450x plus 1650y equals 6,405, and x plus y equals 330, and then solve for one of the variables here and substitute in. Good job. Okay, elimination method, because sometimes adding or subtracting equations will not eliminate either variable. So we're going to multiply one or both sides by a number, add the equations which will eliminate one variable, then solve the equation. Then we substitute in for the other one. So let's see what that means. So we're going to use the elimination method to solve this system of equations. We've got 1 for each of these coefficients, so we can subtract 1 for the other. What we have to do is we're going to multiply this entire equation by a -1 because we need a positive and a negative, but that's going to make this negative, so 2y minus y is y, and 10 minus 6 is 4. So in essence, we're just subtracting them from each other. So now that we have y is equal to 4, we're going to go back into one of these original equations and substitute it in. It doesn't matter which equation as long as it's the original, and the one with those 1 for coefficients are quicker. So our solution is 2, 4. Time for you to check your progress using elimination. So pause the video and work the problem, and then come back and check your answer. 17, -4. Boy, I'd hate to have to graph that one, wouldn't you? So that's why it's so handy to know the substitution elimination method. So then you're not having to graph these really big numbers and taking up a whole page of paper. Okay, now for our standardized test example. They're wanting us to solve this system of equations. Notice we have a problem. None of these are alike. So what are we going to do? Well, we're going to multiply the first equation by 2 and the second one by 3. When you multiply by 2, every term has to be multiplied by 2, so don't forget that. Then we're going to multiply the second equation every term by 3. Now notice we have a positive 6y and a negative 6y, so these will eliminate. 19x is equal to 57, so x is equal to 3. All we have to do is replace x with 3 in either one of the equations. There happen to be using the first one. And then we can solve for y. So y is equal to 2. So the solution is 3, 2. So they had multiple choice questions. The correct answer is D. Okay, time for you to check your progress. So you're going to have to multiply both of these equations by something and then eliminate one of the variables. Okay, the answer is negative 5, 4. Here's the concept summary for solving systems of equations. A couple of things I want you to make note of. When you're solving a system of equations and you get an answer like, say all your variables eliminate and you get an answer like 0 is equal to 120, is 0 ever equal to 120? Well, it isn't. So because 0 is never equal to 120, sometimes you're going to have no solution to your problem. If you get an answer such as 4 is equal to 4, is 4 equal to 4? Always. So there's an infinite number of solutions. So your answer would be infinite solutions.